Rock-forming minerals. So even though we said there were about 3,000 different minerals on Earth, there's only about 30 of those that are actually common minerals. And out of those, 8 to 10 are referred to as rock-forming because they make up most of the rocks in Earth's crust. Some examples of those: quartz. Actually, these are 8 of the rock-forming minerals. You have quartz, which is silicon dioxide. You have feldspars, which are these aluminum silicates. You have mica. You have pyroxene. You have amphibole, olivine, garnet, and calcite. And those are 8 of the rock-forming minerals. So most of the rocks you find are going to have one or more of those in there. And the scale at the bottom is kind of showing our percentages of different elements. So oxygen is the most abundant, silicon is the next most abundant. Then it goes aluminum, iron, calcium, sulfur, potassium, magnesium, and then other. So minerals from magma. So magma is molten rock below Earth's surface. It's less dense than the surrounding rock, so it does tend to rise into cooler areas of the Earth, cooler layers of the Earth. And there it cools and crystallizes. Elements present in the magma determine which minerals form. So different elements form different minerals. So in order for a certain mineral to form, you have to have the elements present to have that mineral. Cooling rate determines the size of mineral crystals. Okay, so the slower the magma cools, the larger the crystals. The faster the magma cools, the smaller the crystals. So again, slow cooling gives this granite larger crystals. So you can actually see these different crystals in the granite because it has cooled slow enough that you get large crystals formed. And minerals from solution. So minerals are often dissolved in water, especially superheated water, but also just in regular seawater and things like that too. When no more of a substance, which we call the solute is what is dissolved. So if we have salt and we put that in water, the salt is our solute. But anyway, so when no more of a substance can be dissolved in water, the solution is saturated. So adding more solute, cooling of the solution or evaporation of some of the water creates a supersaturated solution, because once it is saturated, if I add more solute, now it is supersaturated, if it will dissolve. If I cool the solution, well, the higher the temperature, the more of a solute can be dissolved. So I can dissolve more salt in hot water than I can in cool water. So if I dissolve more salt in warm water and then let it cool, now suddenly I've got a super saturated solution. Or if I have some of the water evaporate, now I have less water, more solute, and I end up with a super saturated solution because the salt does not evaporate. The salt stays even when the water evaporates. Atoms will quickly bond together and mineral crystals will precipitate out. So we maybe get something like this rock salt. Minerals also form when water evaporates. We call these evaporites. So you tend to get this around ancient salt lakes and stuff like that. Like the Bonneville salt flats, for example, are the evaporites left over after the lake dried up.